Good morning. This is Dr. Lukes. As you might be able to hear, I'm a little under the weather today. What I wanted to do is go through a little quick mini lecture before I have you work some problems in class together. So we've been looking at the general Mccabe-Thiele method for ideal systems. And in the problem that we looked at last time, we had that the distillate composition was 90% the more volatile component. The bottoms is 10% the more volatile component. The reflux ratio is 1, and Q is equal to 1. And to do the Mccabe-Thiele method, basically you're going to go through the steps that you see listed here. So we begin by plotting the enriching section operating line. This is the line for everything above the feed. We're going to do that going from the point on the line y equal x, where that's y equals x equals xd. And we're going to draw it with a slope that is L over V, but that turns out in terms of reflux ratio to be R over R plus 1. So we started with y equal x equals 0.9, and the slope has rise over run of 1 over 1 plus 1, or 1/2 is the slope. Next we're going to do the Q line. The Q line starts at the feed composition, which I didn't write in. The feed composition was 0.4. So let's go from y equal x of 0.4, and the slope of this line is going to be Q over Q minus 1. In this case, this is a vertical line starting at 40% and going straight up until we cross that enriching section line. Now we finally do the stripping section line. And to do that, we're going to start at the common point, and we're going to go to where xb is on the y equal x line. All right, so next we're going to step off stages. And we step off stages by starting at the top of the tower at xd. We're going to go vertically over to the equilibrium curve. When we hit that, we will then go straight down to our next tray, and we'll keep stepping these off, going to the operating lines above the feed, or above Q, the first line, and below Q, we're going to go to the stripping section line. Okay, so we have all the stages drawn in, and so what I see is that I have stages 1, 2, I'm counting where they touch the equilibrium curve, 3, 4, and this is going to be where the feed will come in, and then 5, and our last stage, if I have a partial reboiler, will be the reboiler. It counts as an equilibrium stage. So I'm going to have 3 trays above the feed. I'm going to be feeding at tray 4, and then I'll have one tray below, and a reboiler. You have a Kahoot to do. You're going to do this one. Everyone will do it as a Kahoot challenge, so you can do it now or you can do it at home. Let's look now at what happens as I change Q, change those feed conditions. So in our case, we were looking at Q equal to 1. That was a saturated liquid. As I go between 0 and 1, I'm in a two-phase region. 0 is a saturated vapor. As I go to numbers that are negative, it's a superheated vapor, and greater than 1 is a subcooled liquid. And this is going to affect the slope, which will ultimately affect the number of stages that we have, the location of the feed. So we're going to try that next. So what we're going to do is I want you guys to divide yourselves up into small groups. Some of you are going to use Q equals 0, 0.5, negative 0.5, 2, 0.75, 0.1, 3, and 1.2. I want you to identify what type of material is this. So is it a liquid, is it a vapor, etc. And then I want you to tell me the number of stages and the location of the feed. We will still be doing x distillate is 0.9, x bottoms 0.1, z for our feet 0.4, and a reflux ratio of 1. We want to have a partial reboiler and a total condenser. At the end of class, I want you to, each group, submit one copy of your diagram, and in about the last 10 minutes or so of class, we'll wrap this up and show everyone what all the answers are and try and see how changing hue affects our answers. Thank you very much. On Wednesday, we'll be doing kind of a similar sort of exercise, but looking at the reflux ratio. Thank you.